Hi, folks. Welcome. For our next talk, we have three speakers. Ali Langston is an engineer on 2U's Cosmonauts team. In her day-to-day, she can be found working on proctoring, insights, and containerization efforts. Fanil is a software architect at Axum Collaborative. Fanil has been working with OpenEdX since the day it became open source, focusing on various aspects of the platform, including building operations, maintenance upgrades, security, architecture, and most recently, documentation. And Phil is a software engineer with the 2U Purchase Squad and mainly works with e-commerce, front-end app payments, and commerce coordinator. Today, they are presenting Safer, the History and Future of OpenEdX Security. So please welcome them. And who gets the mic first? Thank you.
Hey everybody, good afternoon. Just a quick administrative note, there's a QR code up here. We will be linking to a lot of things in our slides. If you'd like to access that from your computer, it's in red, so it's kind of hard to see, but it is tinyurl. It's tinyurl.com/OpenEdX conference OEC-2023-security-WG for working group. So if you'd like a copy of the slides, that link will get you there. Welcome. We're so excited to be here. I think all of us are really passionate about security in the open source community. This talk is geared for everybody. Maybe you're a security veteran. Maybe you are new to security. Maybe you code. Maybe you don't code. And we really want everybody to feel welcome here. This is the start of a new working group. It's a security working group, and this is our kick-off deck, right? We'd like to introduce ourselves to the community, say hi, and hopefully exchange ideas on like what we're working on and how that might look like in the future. So Dave gave a great introduction to us, but again, there are our faces and our names. Ali and I are from 2U, and Fanil's from Axiom again. So we're really glad to be here today to talk about security. All right, what's on the agenda for today? So essentially, you can read it here, but the general parts are how have we done security in the past? What do we think the security of the future of security at OpenEdX looks like? And how you can be a part of that, right? So that's the general outline of today. And again, if you'd like to grab the URL or the QR code, that's in the corner over here. All right. So let's start with fundamentals. What is a security vulnerability, right? Oh, sorry, I'm pressing the black screen button instead. So a security vulnerability, a vulnerability is a hole or a weakness in the application that allows an attacker to cause harm to the stakeholders of an application. And there are a lot of words here, so I want to give a couple of examples of what might a security vulnerability be. One example is to trick your server to run evil code. Believe it or not, there are a lot of people out there who would like to do that. They might send learners to evil copies of your site, right? Or they might leak your learner's password to the public. Sometimes we occasionally get the thought coming our way of like, well, like maybe this is just a problem that comes when you're at scale, right? Like maybe it's just edX.org that experiences this, but it's not just edX.org that experiences these things. A recent example was a report from one of our operators in Asia that the default configuration of one of our repos let a hacker consume all of their server CPU, perhaps to do Bitcoin mining. It's important to think about security proactively because thinking about security reactively after you have an attacker running amok in your system is really not fun. All right, let's move the focus a little bit. Stakeholders, right? We've defined the what, right? But just as an important question is the who. Who is my stakeholder? And the answer is almost everybody. It's not just your learners. We immediately jump to learners as being the focus as like, okay, I want to protect my learners. But we have a lot of people who are affected by our systems. We have different user personas. You have your core staff, right? You have your developers, the people who work on your platform. You have your customers. You have downstream consumers of your software libraries. A lot of the code in edX is reused by other people in the OpenEdX community. So you have other developers to think about. You have the open edX community itself, I just heard an alert, and the internet as well, right? Because we can also, our code can also spam other people on the internet, right? And so I think that it's important to think about security vulnerabilities, not just from the perspective of harm, but also in thinking widely about the gamut of people who could be affected by a security vulnerability. All right, so there is a great organization called OWASP, and they define something called the OWASP Top 10, which they collect data on lots of security vulnerabilities all over the world, and they come up with the top 10 list, right? And so I want to go over these here now, and we wanted to put some time into this. Just to give, you may be familiar with these already, but I want to give a couple of examples of what each of them have looked like in the open edX world. And for almost all of these examples, we have seen an equivalent security ticket, right, in the security working group, right? So these are not just, theories or ideas. These are actual things that we have received emails about from the public saying, hey, this is an issue. One thing is broken access control, right? The way I've done this before, I've forgotten to add a permission class to a Django REST framework endpoint, right? And by default, right, it might be open to the public, right? So depending on your configuration, you might need to add a permission class to make sure that only people who you want to access the endpoint can access the endpoint. Cryptographic failures. It can be as simple as forgetting to send data over HTTPS, right? A lot of default configurations, because developers work on HTTP, right, which is an unencrypted, right, protocol. Often, when we move to production, sometimes it's easy to forget to include secure or to encrypt the data, right? So that's another option there. Injection, right? This means that every time that a user is coming into your application, you are receiving user input. Please consider validating, filtering, or sanitizing it. Right, really important, because otherwise someone could come in and cause your code to run code that they want to run, and that may not be very fun for you. And also insecure design. So to think about how someone would cheat your system, right? Like in exams, this is a very common thought, right? It's okay, like we're giving an exam to our learners. How can the learner cheat the system, right? This is an example of security design, right? It causes harm, right? Maybe it's a reputational effect. Maybe the learner doesn't learn. That's harm, right? But it is insecure design, right? And so with exams, it's a little clearer, right? We are like, oh, okay, right? Perhaps there is a possibility that students might cheat on their exams. You never know, right? But this can also be at scale, right? So, for example, I think there was an example with a major ticket or a company that takes care of tickets, providing tickets for other people, and they did not consider the possibility of scalping, right? Of a lot of people hitting their endpoints very quickly and running out of all of the tickets that they had for a particular event. And so this I think was actually cited on the OWASP website as an example of insecure design. And so it's important to be thinking about security as we're making our applications. Misconfiguration, thinking about what is on by default, outdated dependencies. A lot of these security items are not just good security practices, they're good coding practices in general. If you are not up to date with your dependencies, it can get very difficult down the line to continue to maintain your repository. So it's not just good for security, it's also good for the longevity of your code base. Auth failures, right? Is it hard to cheat authentication, right? If you're touching authentication, don't hesitate to reach out to us. We're always glad to exchange ideas on how to work with the authentication libraries we have in the open edX platform. But auth is just like crypto. You don't roll your own crypto, and sometimes you roll your own auth, but it's better always to get a sanity check on when you're working with auth, because it can be something tricky to get right. Integrity failures. So, use care with data serialization and deserialization, right? Integrity failures in the OWASP definition deal a lot with deployment, right? Like, for example, checking the SHA-256 sum of the code that you are receiving to make sure nobody has tampered with it. But from a purely development point of view, right, this comes up often in serialization and deserialization of data, right? You might be receiving data from a system, right, and transforming it into a format that the computer is going to understand. But that might be malicious code, right? And so it's perhaps another form. It's a similar concern to the concerns behind injection. Observability failures. a lot when push comes to shove and you're in the middle of an incident or a or of an attacker, on your instance, it's really critical that you're able to observe your app, that you're doing logging, right? That you're logging what's happening, where is the attacker in the process, right, in your application, and also observing metrics such as, how many requests are coming in per second, right? How are the users using my system? So observability is not just good from a security and a perspective. Again, it's also good from a general perspective of how do I deliver a good product for my users. So this has gains in many areas as well. And URL forgeries, right? Whenever you're working with URLs, it's a similar concern with as number 8, right? When you're receiving code from an external area, that's a point of often of vulnerabilities. Another point of vulnerabilities is when you are receiving a URL from another, from an external dependency. I was making sure that that is not poorly crafted. So we get a lot of these security vulnerabilities that we've listed here by email, and which you can also do, by the way, by sending an email to security@openedx.org. We get approximately 70 issues per year. They come in from various institutions, from governments to security labs, to security researchers, to operators. But one of the most important source of security vulnerabilities that we have is you. Over 45% of our issues are by maintainers, and they often come in form of a question. Is this right? Like, is this how we do it? It's probably nothing, but I think these are one of the most important sources of or ways that we keep our platform secure is by looking into these issues that maintainers, these questions that maintainers have up as they're implementing. So if you're a maintainer, please don't hesitate to reach out to us, right? Our email address is security@openedx.org. All right, so that's a general framework on the security, on what security vulnerabilities are, and I will hand it over now to Fanil to talk a little bit about the history of the security working group.
All right. Hi, everybody. Yeah, as Phil said, if you see something, please say something, but also don't say it out in the open public channels, because if you did find a security issue, we want to make sure that you didn't just tell all of the people who want to exploit it also. So security@openedx.org is the place to contact us, and we will help you manage the communications of all of that, and we'll go over that in a bit more detail later. So yeah, a little bit of history about the security working group. As Phil said, the OpenEdX security working group is fairly new. We started earlier this year, and so previously, what did this look like? Previously, we had a different email address. We had security@edx.org. Security@edx.org was a internal group to edX, now to you, and you send your security issues there. They do some stuff. Everything is fine. Problem solved, right? edX handled all the issues. The fixes were made by teams internal to edX, and patches were published first to a small group and then to the public after a little while. That group essentially worked internally as a sort of mini security consultancy and security sort of scoring and prioritization as a service team. So you would send an email. The team internally would score the vulnerability using CVSS, which we'll talk about a little bit more in just a minute. And then it would go to a team backlog with that information so that they would know how to prioritize that against other work. How bad is it? Do I need to fix it today? Do I need to fix it this week, this month, etc.? Because not all security issues are sort of made equal, and this is a good way to help people understand the impact of things that are being reported. So that was part of the service that internal group provided. So real quick, we'll take an aside to talk about CVSS scoring, because this is actually a very important part of what we do, which is helping people understand how bad the security vulnerability is. CVSS scoring, in my mind, is essentially it's the common vulnerability scoring system. It's a industry standard, and it's basically a way of knowing, how much should we freak out about this thing right now, right? And there are links to the spec in the notes if you have them, so please check it out later. The scoring goes between 0 and 10, and we sort of split that into 5 levels. So not actually a problem, low, medium, high, and critical risk. And that's essentially the table that is used by CVSS for doing the scoring. So I thought it would be helpful for us to look at what that looks like. So we're going to go through a couple of different examples, and you can get a better idea of what that scoring looks like, what we think about when we get security vulnerabilities, and how we evaluate that. So this should help people understand if they want to try and do it themselves, if they're not sure about something, or to get a better idea of what we do internally. So this up here, what you're looking at is actually a scoring calculator that CVSS provides. The calculator has a bunch of different sections in it. So you'll see sort of the attack vector, attack complexity, privilege required, user interaction. So all of these are different axes on which we can understand the problem. So an attack vector might be, do they need access to the physical device in order to exploit this, or can they do this over the network? Based on that score, it'll sort of go into the calculator for how bad is this. Do they is the attack really easy to accomplish, or do you actually need to know a lot about what you're doing and actually understand like cryptography in order to exploit this attack? Do you need to already have some level of privilege in the system and then escalate that privilege, or is it that anybody off the street can walk in and just root the system? Do you need somebody else to do something in order to get this vulnerability to be exploited, or can you just do it by walking up to it? When it happens with the scope, we can try to understand. So once you do exploit this vulnerability, how bad does it get? Does it just give you access to one thing, or does that let you then expand your access to other systems and get across and hop over to other places? And then the last three, confidentiality, integrity, and availability, are sort of understanding of impact, which is a really important part of security. Is once this bad thing happens, what is that actually going to do to us? Are we going to lose information? Is there a confidentiality problem? Are we going to lose integrity? Is somebody going to change things in our system in a way where we can't change them back, right? That might be inaccurate now. And you can imagine for OpenEdX, there's a lot of, if there was an integrity issue, often it's, can somebody change their grade so that they're passing all of the courses instead of not passing all the courses? We care about that, and that is more important. And if somebody can do that, that's much worse than if they can't do that. And then availability, of course, if your website is not up, it's not good for anybody. So understanding the impact to availability from a vulnerability is also very important. So this is the basic calculator. There's more complex stuff here that you can add on top of it, but we mostly use the basic calculator to do our calculations and then help people understand that. So let's take a look at an example, which is our first example is going to be an XSS vulnerability. So an XSS vulnerability, cross-site scripting vulnerability, is essentially when somebody will be able to put some piece of input into your system that will get served to other users, and when it's served to other users, code is executed, code that the malicious user provided. So in this situation, the attack vector is the network, right? You can just go put your stuff in, and then anybody else who accesses that page might be vulnerable to it. And the attack complexity of XSS is pretty low. You can pretty much Google how do I exploit XSS and get yourself nice snippets of code that you can drop into a bunch of different places and exploit JavaScript, HTML, and other standard XSS vulnerabilities. Privileges required here would be none. In this case, it was in a system that any student could log into, and since registration for students is free, in most cases, anybody could have accessed it. But it did require user interaction, right? So it requires somebody else to actually go to that same page for this to be exploited. But when they do, you can do things like steal their sessions. And if you've managed to get a staff or super user to go to the page, good news, you are now escalating privileges quite heavily. And that has huge impacts on both confidentiality and integrity. But in this case, not a lot to availability, because even in that case, you wouldn't necessarily be able to bring down this particular system. So given these pieces of information, you can see, this scores a 9.3, which is a critical, which means drop whatever you're doing. This is the thing you're working on now. And that is much more useful than somebody reported there might be an XSS vulnerability. And how much is actually worth to fix it? This is big. You need to do something about it. So it helps people contextualize what to do. Another example, a session ID was not marked as secure, right? Another case where if somebody is on the same network as you, they can listen in on your session ID, The attack complexity is a little bit more complex because now you need to actually be sniffing a network instead of just dropping some text onto an input. You still don't need very many privileges. You do need that user to use that same network, so a little bit more interaction is still required. In this particular case, the system, it wouldn't let you escalate scope out of whatever system it was in, but the confidentiality and integrity, again, was pretty high because once you get access to that, you can lose a lot of information. And then that is a 7.1. It's pretty bad. It's not nearly as bad as when you could impact all of the users. You've just managed to steal one person's credentials. Could still be a high-level user, but it's much harder to get at. So a little bit lower score, still important, but not as important. And then here, in one of the systems, a session cookie was not expiring at logout, right? So in this case, in order to exploit that session cookie, you now need to be on that person's machine copying that cookie. So you need a physical attack. It's still pretty simple. It doesn't require a lot of privileges, but you do need that user to have done this and left their computer somewhere. And the scope doesn't change because this was in a fairly small system again. And in this case, the confidentiality and integrity is low because at the end of the day, you've managed to get a token that is for one user in one subsystem and not for something that would escalate much further. And this is, again, a 3.2. So this, worth fixing, not nearly as big a problem as when all of your learners are sending their session cookies to some third-party server. So it gives you an idea of sort of how we help people prioritize different vulnerabilities so that they can do security work, but do it integrated with all of the other work they want to do, because security work is one of those things where it's not a problem until you've lost a bunch of money already, and by then it's too late to fix it. So understanding when to prioritize this is very helpful because it's easy to want to be doing product and feature work instead. So here's the thing, though. That's what we used to do. But the system we were using previously also had some issues. There were a lot of problems with the way that we were operating the security working group, where edX was the sort of linchpin for making sure everything stayed secure. There were problems with notifications. Notifications were pretty complicated because previously what you could do is whenever we did have a fix, we had a subset of people who were on a mailing list, and they would receive the patch first. They would receive it 2 days before it was made public. The expectation being that they could patch their systems, they were trusted people, and then once they've patched their systems, we could make it public to everybody, and more of the systems would be secure. Idealistically, this made sense, but the effect was kind of problematic because once they have it, what do? Well, most companies and people who are running OpenEdX have forked the edX platform. Our public repo gets a public fork. They get the patch in the mail, but then what do? They apply it to their fork, and now what have they done? They've made it public on their repo before we've made it public to anyone else, and now we have a situation where coordinating when to make things public becomes more complicated. So even though it seemed like a good idea at the time, in practice it turns out it's very hard to keep a secret if you only tell one subset of people and not others when we're all working on the same stuff. We also are starting to have experts in places that aren't edX and 2U, right? The OpenEdX community is getting bigger, the number of components in the community is growing, and the number of people who know about different systems aren't always at 2U edX. So relying on them to solve all of the things doesn't make sense anymore because the expertise doesn't always live there. So because the expertise lives across the community, we want to make sure that we have a process that can leverage the expertise in the right place at the right time. And third of all, edX.org is one deployment of the OpenEdX platform. It is one way in which they run. They run services that not everybody in the community runs, especially because they're running on the tip of master, so they're trying and testing things out that others don't use. But also, there are services that get used there that there are services that OpenEdX uses that are no longer on by default. So when MFEs were first being rolled out, there were UIs that were impacting the security of OpenEdX because OpenEdX was still not using MFEs, but edX.org had already replaced that particular component with an MFE, a micro front end, and so they were not impacted by that same security vulnerability. So prioritization, if it's internal to one organization, can get a little tricky because like this is not a problem for us, but it's clearly a problem for the community. So making sure that we have the right stakeholders in the room when we're discussing that prioritization becomes more important. And it didn't make sense anymore to do that all internal to one organization. So with that, I will hand it over to Ali, who can tell you a little bit more about where we went next and what OEP 60 is all about.
Yeah, so like Vanille mentioned, there were a lot of issues with the old process. So OEP 60, which for those of you who may not be familiar, it's an open edX proposal, we wrote to address some of those issues. And part of that OEP was introducing the Open edX Security Working Group. And drum roll, who's in it? Hello, it's us three again. So Fanil, Phil, and myself are the current 3 members of the Open edX Security Working Group. Also, as part of OEP 60, we defined the working group responsibilities, which are to triage open source vulnerabilities, advise maintainers on security matters, and work on proactive security measures. So much like the old process, which was internal to 2U, we are providing security as a service to maintainers with these responsibilities. I think one of my favorite parts, and probably the thing I'm most excited about as part of this proposal, is the new security release process. As part of that process, we've introduced GitHub security advisories as a way to notify maintainers of vulnerabilities, as well as coordinated disclosures to notify the community of those vulnerabilities, both of which we'll touch on in this presentation. So to start off with GitHub security advisories, why did we choose them? So there's a couple different reasons why we moved to this new framework. One of them is to reduce complexities for security fixes. So internally into you as part of the secure release process, this really cumbersome way to patch vulnerabilities privately before sending them out to the security notifications list. It was prone to a lot of issues because engineers either weren't familiar with it or it was just really unintuitive and painful to use. GitHub security advisories, it's on GitHub. All of us use GitHub. Pretty straightforward, we're familiar. Additionally, it provides a collaborative and private environment for us to patch vulnerabilities. Both of those things are key. We wanted to have other people, regardless of where they work, be able to contribute to security patches and be able to fix things in repos that they may maintain. GitHub security advisories allows us a process via private forks to let anyone be a part of those security patches. And it also provides a way for people to discuss those vulnerabilities before they're made public. And lastly, this is consistent across repositories. This is the part that I love. So previously, with the internal private release process, that was only applicable to edX platform. We have a lot of other repositories across the community that we want to be able to patch issues in privately before everyone else knows. GitHub security advisories allow us to do that. So now across every single repository, there is one way to fix vulnerabilities, create the patch, create the advisory, let everyone know at the same time, and it's not just specific to edX platform anymore. So if you're a maintainer and wondering, what the heck does this look like? I'm just going to walk through a few images of what you might see when you are added to a GitHub security advisory. So this is an example of, I think, the most recent GitHub security advisory that we opened, which is in the LTI consumer library. And so if you are added as a collaborator to a security advisory, you might see something like this. So this is, you would see it in draft. This is published because it's already been fixed. But on this, you'll see the title, affected versions, the CVSS score, which Fanil just explained, so you can see the severity of the issue that you're being notified about, as well as a description. So you'll see, we'll leave some information on there that will be useful to you so you have context behind what the issue is and how severe it is. If you are added as a collaborator, you'll also see the option to work on a private fork. This is where you will be able to patch the vulnerability privately. Anyone with admin access has the ability to create a private fork on the GitHub security advisory, and there's there's a really nice little message from GitHub left on every security advisory on how to use this. It's pretty straightforward. Once you add any code changes to that fork, you have the ability to create a PR, review that PR, and then also run any tests that would normally be run on any other fork or PR for that repository. Yeah, so that's a GitHub security advisory. And I did want to point out that for GitHub security advisories, only repository admins have the ability to create the advisory, create the private fork for that advisory, add collaborators, and if you're a collaborator, you also have access to the private fork, merge the PR, and then publish the security advisory. So all of this is important because of the timing that we have for the secure release process. So if you're a maintainer working on a private fork, once you want to merge it, and you may need to collaborate with an admin on this, we have to publish the security advisory and then add a reply to the security announcement post, which we'll talk a little bit about in the coordinated disclosures, within 2 hours. This is just to ensure that all of the information is available to everyone at around the same time. So that was our goal with this. And if any of this was unclear or you have more questions about GitHub security advisories, GitHub has a lot of really great documentation and a couple more examples on GitHub security advisories. And I'm going to pass it back to Phil to talk a little bit more about the coordinated disclosure process.
All right, thanks, Ali. Hey again, everybody. So now we know what GitHub security advisories are, and we got a demo of what it looks like to work with them. But when does this happen, right? Let's review the coordinated disclosure process, which is how everybody works together to identify, patch, and remediate a vulnerability. We've modeled our coordinated disclosure process off of several open source projects, most notably the Django project. And just like the Django project, we'll have a central forum where security announcements are made. This will be on Discourse, discuss.openedx.org. And if you open the security announcements category, there will be a separate section for security. So subscribe your Discourse account to the security announcements to receive emails every time a post is added there. All you have to do is log in, very important step, you gotta log in, and then otherwise you won't see this bell button, right? You hit the bell button and then you hit watching first post. You do that, and then whenever security notification happens, and only when something important happens, you will get an email in your inbox and you can review it and see if it applies to you. The maintainer who is fixing the vulnerability will write the post. And we'll have templates there so they can just copy and paste. It will be super easy. Every post will be some sort of security vulnerability or security announcement that might require the attention of OpenEdX operators or maintainers, or of the attention of OpenEdX operators to patch their systems, or OpenEdX maintainers to upgrade their code. What the announcement will look like, just like this, it will list the, it will come before the fix is public, right, and list a time at which the fix will become live. So you see patch release date and time. There will be a time when it will become live. And once that time rolls around, the fix will become public, and operators are encouraged to head out to the repository in question, pull the packages, check out the changes, and take a look at integrating those changes into their production environments. Maintainers, on the other hand, are responsible for ensuring that the package is fixed in the latest named release, so that the folks who deploy off that named release can also see those changes in their release branch, right? In other words, when the patch becomes live, right, we also want the patches to be live in the named release branches, because otherwise or the supported ones at least, otherwise the operators who work with them cannot have that security vulnerability patch. Operators, if you have any questions, please check out our Q&A page. It'll be added to over time, so you can hit that watch button at the top of the page to get email updates if any of the content changes. And if any question is unanswered, we'd like to add to this over time, please reach out to us at security@openedx.org. All right, so we've been focused on what the coordinated disclosure process looks like for operators. If you are a maintainer, you might see the other side of the fence, which is when the security working groups comes to you and say, hey, well, we've received a notice of a vulnerability in your repository, an email everybody loves to receive. So as a maintainer, what you might have to do is you might have to respond to one of these notices. You may also be a maintainer who is downstream of a particular security release. If that's the case, please try to update that dependency within a week and report any issues if the security fix breaks you. Not you, sorry, your code. So, again, as a security working group, we are here to help you with anything security related. So don't hesitate to reach out to us by email for any security related questions you might have. Ali and Fanil just went over a lot of this process, but if you were unable to memorize all of it, take a look at our maintainers runbook in the security working group's Confluence page. All right, like we mentioned before, over 45% of all of our disclosures coming into security at openedx.org come in from maintainers. The rest is mostly spam. Most of these are in form of questions, right? If you have a question about whether something is a security vulnerability or not, please don't hesitate to write in. Our job is to make your life easier, not harder. Like I said, if you find yourself on the other side of the fence when we're reaching out to you to let you know that someone found a security vulnerability that might need patching in your repo, we'll try our very best to be very clear about what level of severity the issue is. And it's up to you as a maintainer and as a part of your maintainer responsibilities to maintain the security of the repo to decide how this is best balanced, prioritized, and done. We see ourselves very much as security as a service, security scoring as a service, right? So we provide the score and the severity, right, so that you know how quickly you need to react to this. We definitely understand that maintainers have tons of responsibilities. See all of the other talks at this conference. But what we will try to do is to try to help you remember to resolve those vulnerabilities, and we'll do so in proportion to the severity of the vulnerability. If it's a critical vulnerability, if it's something really serious, we might check in, we'll try to check in with you at least once a week, say how it's going, and make sure that you have all the resources you need to be able to fix the issue. And it will be in proportion to the severity. So you can see this little table here, which is a part of OEP 50, I believe, 60, thank you. So you can see this little table over here, and so you can see that for a low severity issue, we might check in, twice a year. And so these severities come from the CVSS calculator Fanil was talking about, so we try not to invent, right? We try to be a little bit systematic. And so we're trying to use this system to give you a gauge, right, as to how important it is to respond to that security, or to how quickly to respond to the security issue, because not every security issue needs to be resolved right before the morning after. So again, once we reach out to you with the issue and its severity, reach out to us with any questions that you might have on resolving the security issue. We will probably not have all the answers, but we have security experts who can probably help us with that. And we'll make sure that you have a GitHub private fork on GitHub security advisory that you can use to patch the issue. And we can help you with any questions that you have in the coordinated disclosure process, or how to get the security announcement out to the community so that operators can patch the issue on their systems. So that's a little bit of the A to Z of our day-to-day work. Our day-to-day is mostly focused on making sure maintainers have all the resources they need to get the security issues fixed. But we also have proactive security work because we want to be advocates of security in the community. And some of the proactive security work that we're doing includes collaboration. We have a lot of work that we are doing to transition processes from the 2U internal security working group to the Open edX security working group. We're trying to coordinate with other working groups, and that includes BTR, right? Figure out and outline the process for updating dependencies and advising on best practices. And we're also really interested in developer education, right? Like we want to get the word out about how to be secure and how to do it smartly. One of the things we were thinking of is a spot the vuln puzzle, right? Like see a piece of code, like, all right, like what might be wrong with this, right? So that we can all together learn more about how to be more secure as we're writing code. We have a lot of process improvements. Please be on the lookout for that annual security survey. We'll probably put it in an announcement in Discourse. But every year we try to gauge the community and hear things like, how often are you releasing, right? Like, is the security process working for you, right? Do you know of it, right? Are you hearing it? And we used to do this every year with the folks who were on the security announcements list, and we hope to expand the reach of that survey so that we can learn more about everybody's security needs. Let's see. Oh yes, we want to standardize GitHub security configs, right? We're improving runbooks, a lot of work in the background. And technology improvements, right? We're looking into sharpening the saw and making everything more secure. We're really interested in the native tools that GitHub offers to be more secure, looking into Dependabot, looking into things like CodeQL. Our work is public, and it is all, if you look in the Confluence page, in our Confluence page, you can find a link to our issues board. You can see all of our upcoming work there. We'd love ideas, so if you have any, please definitely let us know. All right, so please get involved. If you want to join the security group, find a security vulnerability. If you have any questions about fixing vulnerabilities, please email security@openedx.org. We'd love to hear from you. All right.
Thank you. All right, yeah, with that, we can take some questions. But yeah, you can find all the links here. We will also make sure to connect this slide deck to Sessionize if it isn't already. And we will, when the recording goes out, also make sure it's linked there. Questions? Yeah. I'll repeat the question. Go for it.
Can you say more about how the CVSS scores are calculated, if it's like edX specific or consistent with our industry, and also how should we interpret the difference between an 8.9 versus a 9.1 versus a 9.3?
Sure. So the question is, how is the CVSS score sort of related to edX specifically versus the wider community, and how do we determine that? And also sort of how to read the numbers and what that means for people who don't have necessarily, like, haven't seen those before. So yeah, I can take this one. So the CVSS score actually has, as I was mentioning earlier, there's a second component. There's actually two more components. One of them is an environmental score. So what we looked at today was essentially the base score, which is like not knowing anything about how important that system is to you. How bad is this? You can then augment that with an environmental score. So it's like, for you, how valuable is the LMS to you? So if you are a bigger system and like this teaching part is not actually a part of your business, but just a thing on the side, it being slightly vulnerable, it might not have any data for you. It may be very low risk, like environmentally, it might be like not very relevant to you. Or if it's, or maybe this is a core part of your business and the environmental score is that all of this is really important. I need to know and fix this right away. That environmental score is a thing that you can apply on top of the base score. So when we publish that we're going to when we say we're going to release a vulnerability, as Phil pointed out on the discourse post, we have that scoring information about the severity available. And you can take that base score and then apply it to the environment that is your environment and sort of input your business information there, and that'll let you kind of assess it for you. And in terms of sort of the numerics, I think that can be pretty hard, and that's why we try to provide the full sort of calculation that got you to the number. Some people find the numbers very helpful because it lets them order things. Other people don't find them as helpful as the full context of what the vulnerability is and how it's going to impact them as a business. It's sort of giving people both gives them an option of sort of working however they like to work. I'm not going to do it right now. I'm happy to. If you search CVSS, the spec is fully public and available online, and there's a whole specification paper that has the formula in it. Yeah. Other questions? Yeah, see one here.
So, one of the vulnerabilities you talked about was session theft.
Yeah.
And I was wondering, when it comes to the scope part of that, and talking about, like, what does that actually mean when you're talking about scope? Are you talking about when, like, say, session theft, like a super user account in Django, and they have access to Django Island? Is the scope still restricted to one machine, or does that take into consideration, like, a super user can affect different databases potentially?
So I'll try my best to give an answer on that. But the spec, the CVSS. Oh, sorry. Excuse me. There was a question on, in regards to the scope part of the CVSS scoring, right, and how it might affect. How it affects the score and what are the potential contributing factors, right, to it. I'll try my best to give an answer to that, but the official definition is in the CVSS spec, so that's also an option to look up later. But my understanding is that scope is a measure of whether the vulnerability is allowed to expand into areas of, because usually we think in terms of a vulnerable component, right, a part of the software which is vulnerable. If the attack is allowed to spread to other components of the system, we consider that to be a change of scope, right? And it means that the vulnerability allows the scope of attack to to change, right, and affect more than one component. I don't know if either of you want to add to that.
I think that's great, but I think Dave is also letting us know that we're at time.
So it is the coffee break is. We might have time for one like super quick question, but then it's coffee break. If folks want to stick around afterwards here, you are welcome to. So maybe one more super quick one.
We can take one more now. Otherwise, we'll be down here. Johnny, you want to go? Uh-huh. Sure. Yeah, so the question/comment was right now the large instance working group is working in Kubernetes, and there's a set of Kubernetes-related security OAuth standards, and if this security working group is the right place to sort of discuss helping define those and figuring out what a secure version of the OpenEdX Kubernetes instance is, we're definitely we'd love to chat. I suspect that in this case you have probably more expertise than we do, but I think we can give you a security lens with which to sort of look at that, and we can help figure out how what you think about in terms of security for the deployment relates to the security of other components, and how other processes might need to be integrated together to be able to say, okay, you have a secure Kubernetes, but then inside it is a Django app that is vulnerable. How quickly can you update that? What does the process look like? And thinking about sort of holistically the full life cycle of vulnerabilities at different layers of our system. That's it. All right. Yeah, and with that, I want to say thank you. Yeah, I'm happy to stick around here, or you can find me. I'm usually running around, but I think I'll be here today and tomorrow, so if you have more questions about this, Ali and Phil will be around, I'll be around. Please find us. We'd love to hear from you. Thank you.